This is Unit 11, typo up there, but that's okay. We're going to talk about non-right triangle trigonometry. So if you haven't noticed already, math builds upon itself. So starting from elementary school, once you started to learn how to count and all that, it's just been building. So if you struggled with last unit, come see me, come see your teacher, make sure that you get this straightened out so that this unit runs very smoothly for you. All right, so today we're going to go over 11.1 Law of Sines. So, a quick review, and what I suggest honestly is that you pause this video and try these and then just make sure that you set it up correctly. I'm not going to go through all the calculator calculations, but if you follow along you should be good. So again, I suggest you pause it and then come back and check it, but that's totally up to you. Alright, so let's get this rolling. So I need to find this side length right here, and I notice this is my angle of focus, so I have opposite and hypotenuse, which means I'm going to do sine. Sine of 68 will be x over 2.1, and I'll put sine 68 in my calculator, and then just multiply by 2.1 to get x alone. And then I'll have the value of x. But like I said, I'm not doing all the calculator calculations, I'm just reviewing what you should already know. Alright, so this one, if we focus on the angle, we actually have adjacent and hypotenuse. And if you have any questions on that, again, please come see me. If you don't know why that's adjacent, why that's hypotenuse, let's chat. Okay, if it's adjacent and hypotenuse, we should use cosine. Now remember, sine, cosine, and tangent always take angles and give a ratio. So if that's not easy for you, come talk to me. Okay, I'm going to multiply both sides by 7, put that in my calculator, and I'll have the length. Okay, then down here, if this is our angle, that means that this is opposite, and this is the adjacent, which means I'll need to use tangent of 59.6, and that'll give me opposite over adjacent, and I'll multiply both sides by 3. And then put it in my calculator. And then this last one, the algebra gets a little tricky, but I have opposite and I have, that's opposite, sorry, there we go, and hypotenuse. And so that means I'll use sine again. But because x is in the denominator, I'm going to need to multiply both sides by x and then divide by sine 21. So x will be 9 divided by sine of 21. Alright, so just a quick review on that. If any of that was confusing, please make a priority to come see me before or after school or your teacher. Alright, so with that review out of the way, this is the new stuff. So you should be able, if you want to, pause this and just go through. There's one typo. If you turn to number 8, that should be a 6 right there. Does your equation from question 6 still work? So if you want to pause this, try this. You should be able to teach yourself a lot of the things that we're going to learn on your own. Alright, so triangle ABC is shown to the right. Show how you can find the height of the triangle 2 different ways. So, we have 2 different right triangles because the height will form a 90-degree angle. So we could, looking on the left-hand side, we could say, all right, here is our angle. We want the opposite side, and we have the hypotenuse. So we could say sine of 45 degrees is equal to opposite over hypotenuse. We could multiply both sides by 7.1, and we will get a height of, well, x of 7.1 times sine of 45 degrees. And then I just put that in my calculator and have the height. But I'm going to call this, I'm going to rewrite it, height equals, so that was side C times sine of angle B. I'm going to really focus on that. So that's the first way I could find it, by taking side C and angle B. The other way, I could just focus on this triangle over here. And again, I have opposite and then I have hypotenuse. So again, I'll use sine. Sine of 68.2 will equal x over 5.41, and I'll multiply both sides by 5.41. So I'll have the height is equal to 5.41 times sine of 68.2. But I'm going to replace that just in general. That was side B times sine of angle C, which is kind of interesting. Okay. Now, if we had information for A, we could do the exact same thing. So an interesting thing is happening here. Because they're both H, we can say C of sine B equals little b, or side B of sine of angle C. And that'll work every time with every triangle. So that equation will relate BC, BC. So the sine of the angle never uses its own side. So angle B always produces side B, angle C always produces side C, and we use capital letters for angles and lowercase letters for sides, as you can see. So 6, we just proved it, that equation will work every time. So if we have some of the sides and some of the angles, we can just use this new formula right here. Okay. So 7, sometimes the height of the triangle is outside the triangle, like you see below. So what we're going to do is kind of do the similar thing that we did before. It's like thinking of two triangles here. So we need to find the height, but with the triangles it's separated a little bit. So what I'm going to do is sine of 20.6 degrees is equal to, and that'll give me h over 8.5. So I'm extending this blue triangle out all the way over to h. And so h will be 8.5 times sine of 20.6. And I did put this one in my calculator. I got 2.99. And now I can find the length of AB pretty easily. So what I'm going to do is I'm going to actually find this angle right there. So I know that a straight line will add up to 180. So I know that this is 56.3. And then I can find the length of AB. Now, if any of this is not making sense, please email me, please come see me, or pause the video and go back and think about it. Because sometimes you're just watching this video and just listening and not really thinking. And that's where you'll really learn, when you stop and think about it. And if you come see me, I'll ask you questions to hopefully make you stop and think about it. Okay, so side AB. I'm going to take sine of 56.3 again, and that'll give me 2.99 over side AB. Now I'll have to do a little bit of algebra again, but I'll need to multiply both sides by side AB to get it alone. And then I'll have to divide. So side AB will be 2.99 divided by sine of 56.3, which will give me 3.59. All right, so I want to check that equation from number 6. So if you remember, it was B sine C equals C sine B. Capital letters for angles, lowercase letters for sides. So if you see here, here's angle C. Oh, sorry. Come on. Capture that. Anyways, you can see it right there. Don't worry about that. Sorry. Here's little c. There is B, and we don't have A, so we're not going to worry about that right now. Okay, so side B was 8.5, and then sine of C was 20.6. And then we found side C. It was A to B, if you remember. We just found it right here. So it's 3.59. And then angle B is the 123, so sine of 123.7. Now if you put both of those in your calculator, you're going to get 2.99. So yep, our formula worked. And I just want to show you, if you remember, just connecting this to what we learned before. So obviously opposite over hypotenuse, sine, right? So this is just kind of adding to our knowledge about sine. But I want to show you, if you remember, we learned about the unit circle a while ago. And the unit circle, if you go up to 56, just right about there, I guess. If you go out to 56.3 degrees, okay, 56.3 degrees, or if you go out to, so if you remember, 56.3 degrees was right there, or if you go out to 123.7 degrees, the reference angle is 56.3. Okay, so just noticing that we used 56.3 there to kind of help us come up with the law of sines, to show you the law of sines. But notice that they would have the exact same y value. Exact same y value. Here's the y-axis, here's the x-axis. So the reference angle will help us still calculate that correctly. Okay, so why are we learning about the law of sines? So here's the deal. The Pythagorean theorem only works on right triangles. And really, so trig functions, sine of opposite over hypotenuse, cosine of adjacent over hypotenuse, tangent of opposite over adjacent. We can only use that in right triangles, which is why I had to extend this out to create a right triangle. The math worked, right? Because I created a right triangle. So the problem is the tools that we have, the skills that we've been learning only work with right triangles. But in real life, you're not going to only work with right triangles. So this is why we're here. This is why we're learning about sine, law of sines and law of cosines. Now this is going to pull back a little bit of the stuff that you learned. You learned this in 7th and 9th grade math. You learned about angle congruency. So you learned about side, angle, side. And you learned about side, side, angle. Now you didn't write these all out, but you listed them like this: side, 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 angle, side, angle, 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 side. And then there was this one that didn't really work for congruencies, and your teacher maybe made a big deal about it, maybe not. But angle, side, side, which spells a bad word, so I got to be careful with that, obviously, right? So angle, side, side did not work in proving triangle congruence, but all of the others did, and I missed angle, angle, angle. So I'm going to reference those, but we're not going to really use them to prove everything, but I'm going to talk about those a little, okay? So knowing two things will help us solve any triangle, okay? So knowing these two things above will help us solve any triangle. Okay, so once you realize you don't have a right triangle, you're going to analyze side, angle, side, 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 angle, 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 right? You're going to analyze that. But not all of them will work. Okay, so we'll go into that a little bit more. This part. Okay, so we'll go into that in a second. Okay, so with the law of sines, our goal is to find missing sides or angles in, it's called oblique. You don't really need to memorize that word, but these are non-right triangles. So oblique triangles, non-right triangles. So that's our goal. And then you're going to remember capital letters are angles, and then lowercase letters are sides. And if you notice, angle B always forms side B. Angle A will always form side A. And then angle C, if you just take your fingers and follow that angle out, you'll hit side C. So you need to know that as well. Okay, so our goal with the law of sines is going to help you find any sides or angles for non-right triangles. Okay, all right, and so we're going to modify that equation that we got in number 6. And we could have kept going with the a's, but obviously I didn't. What we're going to do is divide by b. And then we're going to divide by c. So you're going to have sine b over b, sine c over c, and that'll also equal sine a over a. So this is the law of sines, right here. So this is the goal, what it does, but this is the actual law. A over sine a equals b over sine b equals little c over sine c. And you can use any combination. If you just want to do a over sine a equals c over sine c, that's fine. And you notice all I did was over here, sine b over b equals sine c over c. You don't have to use all three. Or you can flip them. Sine a over a equals sine b over b equals sine c over c. But notice all the angles are on top and the sides are on bottom, or all the sides are on top and the angles are on bottom. That does have to be consistent. You cannot say sine a over a equals b over sine b, because that's just not true. Okay? So we proved, if you remember back here, we proved that c goes with sine b, b's, so, and then if we use the algebra, the sides always have to both be on the bottom or on top, you choose. Okay, so this doesn't work with all congruencies. So these are the two things that I was talking about. So these really only work with angle, angle, side, or side, angle, angle, right? So they don't have to be in that particular order, but they only work with angle, angle, side, angle, side, angle, and then sometimes SSA. Okay, now you don't need to memorize this, because if you get going on one and it just isn't working, you're gonna know, okay, the law of sines doesn't work, and later we'll learn the law of cosines and other things to help you out there. But if law of sines isn't gonna work, you can't force it. So you'll learn pretty quick that it's not gonna work. Okay, so let's look at a few examples. So here our goal is to find AC, which is little b. And we also have little c. And then obviously we have big A and big B. All right, so let's do it. So if I set this up, so since I want to find little b, I'm going to start right there. I'm going to just throw that out there. Little b over sine of 22 degrees equals, now I also have information about angle A, but I just want to kind of show you, I don't have information about side A. So if I just write this down, it's really no good for me. It's not going to help me at all, right? Because now I have two unknowns and I'm just stuck. If you have two unknowns, you cannot solve for the letter. So kind of think about what we can do. The only other information we have is side C. And I can't use the Pythagorean theorem, number one, because it's not a right triangle, and also I don't have enough sides. But if you remember, the insides of a triangle always add up to 180. So what I can do is do 180 minus 18 minus 22 degrees, and I can have side C. Or sorry, angle C, not side C. I already have side C. So side C is 24, and then I have sine of 40 degrees. Okay, so now I have one unknown, and I use the law of sines. You just got to be smart about it and pick and choose what you have and get it so you only have one variable. Okay, so kind of think about that and what I did. Okay, so what I'll do is I'll put this side in my calculator, and then I'm just going to multiply it by sine of 22. And I'll get that side B is 13.99 units long. And I'm done. So it only wanted me to find that side. Okay. All right. There we are. So we can use law of sines when we know. Here we knew angle, side, angle. And again, I can't force something to work that's not going to work. So if you can't use law of sines, you won't be able to create something like this. And so you can memorize, oh, okay, law of sines always works with angle, side, angle, but you don't have to, okay? You don't have to. Okay, here I have, well, I have side, 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 angle, side. So if I didn't have this angle, and I just thought, ooh, I have side, 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 well, I'd have little a, and no matter how hard I tried, if I did little b over sine b, and little c, which is 20, no matter which ones I use, if I decide, okay, I'm not going to use sine c, right, okay, I still have two unknowns. And if I decide, oh, okay, I'll use these guys, I still have two unknowns. So with all the sides, side, side, side does prove congruence, but it doesn't work with the law of sines. So it's imperative that you do have an angle. Yeah, you need an angle. So you need at least one angle. And then we have to be careful, if you only have one angle, you have to be careful about what pieces you're given. But with side, angle, side, right? So side, angle, side, it's trapping that. We're pretty good to go. Actually, I lied to you. Side, angle, side does not work. I meant, sorry, side, side, angle. Because we're going to have to use little a. So it'll be side, side, angle. Or side, side, angle that way. Either way. But side, side, angle works. We've just got to be careful because it doesn't always. Sometimes it can form two triangles. We're not going to worry about that today. But it's a possibility, so we do got to be careful. Okay, so, all right. I need to find angle C. So because I want to find an angle, I'm going to write sine C here. Whatever I want to find, I like over here, I started with putting that little b up there. Whatever I want to find, I start putting it on the top. It just makes the algebra easier. You can do it other ways, but it just helps me know where to begin and know where to go. Okay, so sine C has to have little c on the bottom. And this will equal, now the only angle I have is A, so I'm going to use sine of 82 over little a, which is 29, length of A. Okay, and again, I'm going to put this in my calculator, and then I'm going to multiply by 20. Now, unfortunately, that's not going to give me the full answer. So sine of C equals this decimal that I have. I'm just going to write decimal, because I don't want to put that in my calculator right now. So I put that in my calculator to get this decimal. Now, I still don't know angle C. So you're going to have to remember, we've got to undo sine. And the way to undo sine is to use its inverse. So what I'm going to do is inverse sine to both sides. Remember we learned this last unit. That'll cancel off sine. And so inverse sine of that decimal that you got will give you 43.07 degrees. Mission accomplished. All right, so law of sines helps us find missing sides or angles in non-right triangles. If there's not a 90-degree angle, you gotta use different strategies because SOHCAHTOA won't work. Pythagorean theorem won't work. Okay? So we can use law of sines when we have angle, side, angle, side, angle, or angle, side, angle. But you need at least one angle. You can't do it if you don't have an angle. But we do need to be careful with this one. So the problem with that one, and it'll always work if you have all the sides though, okay? So if you know all the sides, so if you have side, angle, it'll always work. But if you only have side, angle, you do have to be careful. And I'll show you an example of why we have to be careful with that one. Okay, number 3, do a few more. And again, I suggest you pause this and look at it, go over it, okay? So, on number 3, we have angle, angle, side. Angle, angle, side. Or you can reverse it, side, angle, angle. Okay, now if I try to set this up, just setting it up, can I find other pieces, right? So I can do 7 over sine 44 equals c over sine 53. Yeah, I only have one unknown, it'll work, okay? So AAS, SAA, it works. Okay, let's take a look at this one. I have side, angle, side. Side, angle, side. So if I try to solve with this one, so I have sine of 93, which is big B, but I don't have little b, okay? And then I don't have sine of A or sine of C. And I don't have A, right? But I do have little c, okay? So if I try to use, sorry, the wrong thing. If I try to use that, I have 3 unknowns, and I will not be able to solve for anything. Now, if I use this one, again, I have 3 unknowns, so I won't be able to solve for anything. So let's just get this out of there, right? That's no good. But even if we look at this one, we still have 2 unknowns. So, nope. Side angle side's not going to work. Okay, so notice we're able to create this so we only had 1 unknown, so it worked when we had angle, angle, side, or side, angle, 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 side, angle, angle. Side, angle, side will not work. It will not. Okay, here we have side, oops, sorry, we have angle, angle, side, angle. Or if you go this way, we have angle, side, angle, which is the same thing. Okay, so this is a little different than the first one, right? Remember the first one was angle, angle, side, or side, angle, angle. Now the side is sandwiched. So let's see if this works. So sine of C has an unknown side C. That's a lowercase c, by the way. All right. Sine of A also has an unknown. That's supposed to be an A. Okay. And then sine of, we can find B. We can, right? Because remember, the inside of a triangle always adds up to 180. So if you take 180 and you minus 30, obviously you have 150, minus 61, you're going to have 89 degrees. So sine of B is 89 degrees, and we have side B, which is 8 long. Okay, so if you look here, we have one unknown, A. If you ignore this and use sine 89 over 8 and sine 30 over C, we have one unknown, so it will work. So yes, angle, side, angle will work. So just proving what we talked about on the previous page, angle, side, angle, 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 side, those are for sure, they will always work. And don't forget, it can be side, angle, angle. And then SSA will sometimes work, but when it traps, as you notice, when the angles are trapping the side, where was it here? Sorry, when the angle's trapped between the sides, there's nothing we can do. Okay, so let's do a few more examples. So solve the triangle, and you must sketch a picture of the triangle. Okay, so I know it's not a right triangle because 90 plus 13 plus 22 does not add up to 180. So I know it's not a right triangle, so I'm not going to draw a right triangle. Okay, side C, or sorry, angle C is 13 degrees. Side C is 9. Angle A is 22 degrees. And then it is unknown, right? We don't know. So we need to find A, we need to find angle B, and little b. So, angle B, easy, right? 180 minus 22 minus 13 leaves me with 145 degrees. Okay, so I have angle, angle, side. What did we talk about? Angle, angle, side. It will work every time. Okay, and if you set it up and it doesn't work like we did with this middle one up here, like, so you don't have to memorize it, I'm just going to keep pointing it out, what works and what doesn't. Okay, so let's find, it doesn't really matter, but let's find little a first. So I want to find little a, and whenever I want to find, I just write that, and that'll be divided by sine of big A. And then because I have the information for C, I'm going to use C. So that's a 9. Little c is 9 long, and then that'll be sine of 13. So all I'm going to do is multiply both sides by sine 22. And then put that in my calculator, and I'll have that little a is 14.98. Okay, I'm going to do the same thing with little b. Now I need to find little b, and I'm going to have sine of 145 equals, and then it really doesn't matter, but I'm going to stick with c because it was nice. And then I'll just multiply both sides by sine of 45, 145 I mean. And I'll get little b is 22.94 long. All right, so I want you to try 5 and 6. Really pause this, try 5 and 6. I'm going to draw them right now. Okay, here's angle A, it's 103. And then side A, it's 39. And then side C is 35. Okay, so this is why, so if you notice we have angle, side, side. Angle, side, side. Sorry for the bad language. Okay. So this one's gonna work, and on the homework I'm probably only gonna give you ones that do work, but just know that sometimes, now it mostly happens when you have acute angles. It almost never, I don't think it ever happens when you have obtuse angles. But sometimes this guy right here can swing, okay? It can swing around and just form this teeny, teeny, teeny side length. So basically there's two possibilities. It could hit here, right? It has to be 39 long, or it could swing up and still be 39 long, but it usually doesn't happen there. So that's why we just have to be careful with the ASS. If you take honors, if you would have taken honors, you'd learn how to recognize when it works, but we're going to try to only give you ones that work on the test and on the homework and on the quizzes. Okay, so you need to find angle B, angle C, and side B. Okay, so go for it, try it. Alright, so hopefully you tried that. Oh no, what am I doing? Oh, I'm on the wrong one, sorry. Okay, hopefully you found that C was 61 degrees, B is 16 degrees, and then B is 11 long. Okay, so I'm going to go over that. Fast forward if you did get that though. Okay, so to find angle C, I want to find angle C, so I did sine of C, and then that was divided by 35, and then I had all the info for A. Notice since sine was on top, I have to have sine of A on top. But remember, A is 103, and then it's 39. So I'm going to put this in my calculator. I'm going to multiply by 35, and I'm going to have sine C equals a decimal, right, that I got in my calculator. Now, I have to get C out of sine, so I'm going to have to use the inverse. So whatever decimal I got, I'm going to do the inverse of that. That'll cancel out, so C will equal the 61 degrees, and I rounded to the nearest whole. Okay, then all I'm going to do is subtract those. 180 minus 103 minus 61, that leaves me with angle B, which is 16. And then I'm going to find little b, by doing the calculations like this. That's 103. And then I'll just solve for b. All right, try triangle 6. Okay, so if you got this when you tried it, or pause this, try it, make sure you get it. If you got all this, great, go do the homework. If you did not get this, you were given angle C. You were given angle B. So angle A should be easy. You just do 180 degrees minus 100 degrees minus 34 degrees. So just remember the inside of a triangle always adds up to 180. Okay, next, you were given side B, right? Now, you can't use SOHCAHTOA because it's not a right triangle. So what you had to do is remember the law of sines. So we want to find, let's say we want to find little c first. So whatever I want to find, I put there, little c. That corresponds to sine of 100 degrees. And then I just have to use the combination that I was given. So I was given the 8, little b, and I was given big B. So I just set it up. Remember, I'm just using this law right here. Okay, all I do now is put that in my calculator and then multiply both sides by sine 100 and get my answer of 14. Okay, now I cannot use Pythagorean theorem because this is not a right triangle. So to find little a, I took sine of big A, right, which was the angle, and that'll be equal to, and again, I'm going to use the same thing as before. And then just use a little algebra to get A alone, and I got the 10.29. All right, there it is, law of sines. So you got some homework to do to practice. Not too long. There it is. Good luck. Let me know if you need any help.